So yesterday was geometry, just using shapes that we know, circles, rectangles, trapezoids, triangles. I think that was it, like basic geometry shapes to find area. Today we switch it up a little bit, and instead of actually finding area, we're going to be estimating area, which seems a little weird. Like, if we could find the area exactly yesterday, why would we estimate it today? It's because if we start with an estimation, we can sort of fine-tune our estimation and get it to be an exact answer using calculus. So we're not doing that yet. So today it should feel easy. Like, why are we doing this? But once we know what we're doing today, we can do it better in the days ahead and get an exact answer instead of an estimation. We'll see if that makes sense after we finish this lesson here. So today is Riemann Sums. Using rectangles to approximate area. And again, this is exactly what we did day one in here when you took the toilet paper and you measured area of those yellow curves. Like, you were doing Riemann sums. You didn't know it at the time, but that's exactly what Riemann sum is use rectangles to approximate an area. And we can jump into an example because there's no deep concept stuff we need to cover. Like, area of a rectangle, that's what you need to know in order to work a problem. So I guess maybe we should area equals length times width. Okay, now we've got our background information. Now we're ready to work a problem. Find an estimate of the area of the region bounded by f of x equals x squared and the x-axis between x equals 0 and x equals 2. We need to specify more how we want to do that. So using, you know what, let's pause there. Let's pause there and draw the picture that it's talking about, and then we'll worry about more of the details. So we want to estimate the area bounded by f of x equals x squared between x equals 0 and x equals 2. So let's sketch that area. So I know what a parabola looks like. I'm only going from 1 to 2. Eventually we're going to squeeze 4 rectangles in here, so don't make this picture too small or else your rectangles get really small. On the picture much like we did yesterday. So my shaded area is the exact area, but that's not really what we want. So I'm shading lightly because I'm going to draw more pictures on here in a minute. So there's the exact area between x squared and the x-axis, between x equals 0 and x equals 2. But we want an estimate of that area. And so it will specify how to do that using a right Riemann sum. We'll talk about that in a minute. and 4 subintervals. And the books sometimes just say 4 intervals. So a subinterval versus an interval is the same thing in this context. Okay, 4 subintervals. So I want 4 rectangles is what that means. On 0 to 2. So I need to figure out how wide each rectangle should be. Now, for this one, that's probably pretty easy. Width of each rectangle. So before we even talk about a formula, if I want to squeeze 4 rectangles into here, how wide is each rectangle going to be? And my rectangles are going to be running up and down. So if I want to put 4 of them in there, how wide is each one going to be? 1/2. Because the total width is 2, and n is 4, like the number of rectangles. So my width of each rectangle is going to be 1/2. So that'll put 4 rectangles in there, each with a width of 1/2. Now, a right sum versus a left sum tells us where to draw, or maybe where to find, the heights. Okay, so I'm gonna draw in my widths here, but those aren't rectangles right now. Just got it divided into 4 spots. And so you've got options here. You can draw a rectangle from the right. You could draw a rectangle from the left. And tomorrow we'll even draw a rectangle in the middle. So this one, though, wants us to draw from the right. So that means that the right end of the rectangle is where we'll draw, or what we'll use for the height of the rectangles. To approximate the area, so not an equal sign because we're approximating with these rectangles. And all we're going to do is add up the area of 4 rectangles. Books sometimes go a little crazy with formulas here, because if you remember from pre-cal, there's all sorts of stuff that can go with the sum formula. We're not really going to do that. All we want to do is add up 4 rectangles. So don't overcomplicate this. We're just going to write out the area of the 4 rectangles and add them up. So Riemann sums, when you look in calculus books, they go a little crazy with formulas and it gets overwhelming, but all you're doing is adding up rectangles. Don't lose sight of that. Emily?
How did you decide the heights again? Did you just draw a triangle?
I drew the height from the right side of the rectangle, as opposed to if I had drawn it from the left side. A left sum would look like this, and this, and this. If I was coming from the left side of the rectangle, you got to look at one rectangle at a time. Maybe this is better. So on that rectangle, I can draw the height from the right, which is what I want. Or I could draw it from the left.
Yeah, okay.
And so depending on the shape, you can tell immediately whether your estimation is going to be an overestimate or an underestimate. So for this one, if we come from the right the whole time, is that going to be an overestimate or an underestimate? Over. All those rectangles are above the actual curve. If we came from the left, it'd be an underestimate. If we did a middle, that'd probably be the most accurate, but I don't know if we know enough to say if it's an over or an under. We'll do middles tomorrow. Today is just left and right. So don't worry about formulas, just worry about adding up the rectangles. So my first rectangle, I'll try to color code these. Let's see, the width is, or the base is 1/2, because they're all 1/2. And the height was the height right here. So that's the function at 1/2. F of 1/2 is a y value. It's the y value at 1/2. So it's that height right there. That's the first rectangle. We'll fill in some more in a minute. Second rectangle, I'm going to make this one a different color just to... So there's my second rectangle. Its width is also 1/2. Its height is right there. That's the function evaluated at 1. And we'll go figure out what those heights are in a minute. Third rectangle. What's the width of the third rectangle? 1/2. And how will I find the height of the third rectangle? F of what? F of 3/2, F of 1.5, either way. And then the last rectangle, 1/2 times F of 2. 4 rectangles, 4 expressions. So now I'm just going to figure out what those are. F of 1/2. Well, f of x was x squared. So 0.5 squared. F of 1, so 1 squared. F of 3/2 would be 3/2 squared. And f of 2 would be 2 squared. And that's a safe stop. So this is a great place to do a safe stop. Like a lot of times, like yesterday, like, oh, you could safe stop it, but you're safe stopping 2 times 1/2. Like, who cares? This is a good place to use a safe stop, because if you want to keep going, there's either a lot of work by hand or there's a lot of things to type into a calculator that we don't want to mess up. So we can safe stop that and be just fine. Plus, it's a good safe stop, not just for like work, but like concept. You can see exactly what's going on. You're adding 4 rectangles. And if you keep going, then you sort of lose the idea that you were adding things. Now, because I want to compare in a moment, I'm going to add them up. And you get 3.75. Which we already said was an overestimate. And again, we just know that because the rectangles are above the actual shape, so it's an overestimate. And because it's an overestimate, we call it an upper sum. meaning I don't know what the real sum is, but the real sum is not bigger than 3.75. Like, the real sum is definitely lower than 3.75. I don't know what it is, but it's less than 3.75. Now, this next statement, don't memorize. This is one that you figure out each time that you need to figure it out. For an increasing function, the right sum over or underestimates. For an increasing function, which is what we have, overestimates. Because if you're increasing and you're taking the right-hand sum, you'll always be taking the bigger number. But don't memorize that, because there's like 4 different ways I can ask that question, and then you get confused on your memorizing. So if you see a question like that, draw a little picture and think about what's happening. There's an increasing function. If I come from the right each time, well, that's going to be an overestimation. So the other combinations would be for a decreasing function and for a left sum. And so you can combine all those and you end up with over or underestimates, but don't memorize that. Just figure it out when you need it. All right, let's do the same region, but a left Riemann sum. So kind of the same problem, same area to start with, but we'll estimate it from the left. Now, if you really want to be confusing, you could draw your left rectangles on top of the right rectangles and really mess yourself up. I'm not going to do that. I'm going to draw the shape again. Parabola. We're only going to 2. So there's the area that we want to estimate. It's the same as last time. I mean, the same starting area. Left Riemann sum. I guess I should have said with 4 intervals. Similar problem. So there's my 4 intervals. But now I want to come from the left. Not equals, area approximately equals. Same thing, write out just adding the rectangle. So the first rectangle is kind of tricky on this one. Its width is 1/2, because all the widths are 1/2. But on this first rectangle, if I come from the left, how tall is this rectangle? 0. So that's kind of weird, but I'm going to write it that way anyway, f of 0, which is 0, which would zero out that whole term. But I'm going to leave it there for now so that I see my 4 rectangles in a moment. So the next rectangle, coming from the left, be that green one, width of 1/2, height at f of 1/2. The next rectangle, coming from the left, f of 1. And then that last rectangle, (1/2) f of 1.5 or 1.5 or 3/2, however you want to phrase it. The trick or the mistake that people make is they'll get used to not looking at the picture and trying to write the formula, and they'll put another term on there. They're like, oh, look at the pattern, f of 0, f of 1/2, f of 1, f of 1.5, and it said to go to 2, so I'll put f of 2 on there. But then that'd be 5 rectangles. So be careful when you get to this stage. Do a quick check. 4 intervals. I better have 1, 2, 3, 4 terms there, 4 areas to add up. Is this a safe stop? Do you guys know if that's a safe stop?
Yeah. No.
I don't know if we've talked about it. It's not a safe stop. You can't leave f of stuff in there. So you've got to plug into the function value. So it's almost a safe stop, but not yet. F of 0 would be 0 squared. F of 1/2 would be 1/2 squared. F of 1 is 1 squared. And again, that would be a safe stop. If it's calculator ready, although depending on your calculator, that previous line could be calculator ready if you've defined some things. So, and be careful saying that. If you're ready to type it into a calculator, like a simple calculator, and get an answer, then you can be done. That's a safe stop. And I would stop there because you don't want to risk messing up, parentheses and squares and fractions. You don't want to mess that up. I'm going to go ahead and do it just so we can see that it is indeed less than the previous answer, which is not surprising because all of those rectangles are under the curve. That's an underestimate. And we could call it a lower sum. Meaning, I don't know what the area of that thing is, but I know that it's not lower than 1.75. Like 1.75 is the bottom it could be. 3.75 is the top it could be. So the actual area is somewhere in between 1.75 and 3.75. And who knows, depending on the situation, that might be good enough, or you might feel like that's not very accurate. So, if we weren't satisfied with that, what are some things we could do to get a more accurate estimate? Okay. Average what? I think I know what you mean, but okay, average the right and the left. Yeah, I don't know that would be exactly it because it's curved, so it's probably not still exactly right, but I feel like that would be pretty close. So that would be a good way to go. You could take an average of the upper and lower sum, or the average of the right and left sum. What else could you do? There's like at least 4 answers to this, so throw me some more options.
Does it have something to do with the derivative, maybe? Or like the slope of the...
Yes and no. It has to do a little bit with increasing or decreasing, but it also has a little bit to do with concavity, but that's a little bit beyond where we want to go. So just using what we've known and the things that we played with, how could we change this problem to get a better estimate of that area? Okay, so what shape would you propose? We could use trapezoids because it certainly feels like trapezoids would much more closely, model that curve, right? If we connected those points with trapezoids, I feel like we'd have a pretty accurate answer. Tomorrow, we'll do exactly that. We'll use trapezoids. So yes, that's a good answer. What else? What else could we do? So you could use the integrate, like if you like to be completely accurate, the area would equal the integral from 0 to 2 of x squared dx. That is true. That would be the accurate, exact answer. But we don't want the exact answer. We want a better estimate. Which, I don't know, that sounds weird. Like, why wouldn't you just take the exact answer? Other things we could do to get a better estimate? More boxes, more rectangles. Now that could get annoying, right? Like, clearly 6 rectangles would give you a better answer, and 100 rectangles would give you a really good answer, but I don't want to take the time to write out 100 rectangles. So there's a trade-off there. But yes, more rectangles would work. And this sort of gets to, this is where the calculus comes in. As n goes to infinity, that would be really difficult to do by hand, right? Like impossible. But as n goes to infinity, your estimate would your estimate would become perfect. It wouldn't be an estimate anymore if you used an infinite number of rectangles. But you can't really use an infinite number of rectangles, but that's because it's a limit, and limits are calculus, so that's sort of the link of where we're headed. But yes, back up. If you use 6 rectangles or 8 rectangles, your answer would be more accurate. And there's one more that we'll do tomorrow. We could use the midpoint height instead of the left height or the right height. I feel like that would give us a more accurate answer. And we'll do midpoint tomorrow as well. All right, let's go a little faster here. Maybe we got the hang of this. All we're doing is adding rectangles. Number 2, find the upper sum. So upper means an overestimate. I haven't said whether that's a right or a left, but that's just because it depends on the problem. Find an upper sum for the area under f of x equals 9 minus x squared on 1 to 3 with 4 subintervals. For some reason we use 4 a lot because less than 4 is really inaccurate. More than 4, it's just a little tedious in terms of writing out all the rectangles. So 4 seems to be a good kind of middle ground of accuracy without having to write 8 rectangle equations out. Let's see, 9 minus x squared. So that would be an upside down parabola that starts up 9. I guess just plot some points here. If I plug in 1, plug in 1, 9 minus 1 is 8. Plug in 2, 9 minus 2 is, or 9 minus 2 squared is 5. 1, 2. And if I plug in 3, 9 minus 3 squared is 0. So there's my picture. I want the area from 1 to 3. Again, very lightly shade if you want to shade that, because that's because we're going to draw some rectangles on top of that. So your picture can get a little out of hand if you're not neat and you're not careful. Okay, an overestimate, because it's an upper sum, I guess let's back up here. What's the width of each interval going to be? It's going to be 1/2 again. So I can divide my region into the 4 intervals. Now if I want an overestimate, an upper sum, is this going to be a left Riemann sum or a right Riemann sum? Or do you know? Let's look at one particular rectangle. If I want my rectangles to overestimate the area, do I want to use the left-hand height or the right-hand height? The left-hand height. So for this problem, an overestimate is a left Riemann sum. But be careful, over doesn't always mean left or right. It depends on if it's increasing or decreasing. So you just have to be careful and pay attention. So an overestimate for a decreasing function means we want a left Riemann sum. But again, I don't memorize that. I figure it out and think about it each time. If I want to overestimate, well, pick the heights that are above the shape, above the curve. So area equals, or area approximately equals. And maybe it's helpful to draw the rectangles on there. Kind of clearly see that you've got an overestimate now. It's going to be an upper sum. So the width of the first rectangle is 1/2. The width of all the rectangles is 1/2, and the height would be f at 1. The second rectangle has a width of 1/2, and we'll grab the height f at 3/2 or 1.5. You guys with your fractions, that's good that you like fractions.
Yeah, I'm confused how you're doing this.
So this is my second rectangle. Its width is 1/2.
Mm-hmm.
Its height, I'm going to grab right there, which is the height, which is f, the y value, at 1.5.
Oh, okay.
Better?
I think so.
So see if you can finish the next 2 rectangles. What do they look like? Is that what yours looks like? And again, you get to the end and you double check to make sure you did 4 rectangles. And you start to see the pattern. 1, 1.5, 2, 2.5. But we don't go to 3 because we were using a left Riemann sum, so we don't ever use that rightmost number. And we have our 4 rectangles, so we stop there. Again, the common mistake is to use all 5 heights, but there's not 5 rectangles, there's only 4 rectangles. Not quite done yet because that's not a safe stop. So f of 1 was 8. F of 1.5, well, in the spirit of safe stopping, that's 9 minus 1.5 squared. Right? Like, don't risk it. Just leave it. F of 2, if we plug in 2, we get 5. In fact, we kind of already did f of 2 when we were plotting this thing. Plus 1/2. F of 2.5, again, I don't even want to do it. I'm just going to say 9 minus 2.5 squared. Like, leave it at that. That's a perfectly good answer, and I'm going to leave it at that. Because I don't want to risk. That's a lot of calculator strokes to mess up a parentheses or an exponent somewhere. So leave it alone. Safe stop. Like it. All right, let's do one more. Go a little bit quicker on this one. Yeah, we'll go a lot quicker on this one. Find the right-hand sum. Oh, I guess that's a slightly different phrasing. Right hand means the same thing as right Riemann, come from the right. For area under f of x equals 1 over x on 2 to 6 with n equals 4. N equals 4, probably figured this out from context, but that means 4 rectangles. 4 subintervals. Let's see. I'm going to very roughly sketch this one in because I know what the picture looks like. 1 over 1 is 1. 1 over 2 is a half. 1 over 3 is a third. A fourth, a fifth, a sixth. And I want to estimate from 2 to 6. That was kind of nice that we went from 2 to 6. Like the combination of your x interval and the number of rectangles, usually the book and Mr. Wolf are nice. Nice, what do I mean by nice? What's the width of that rectangle, of each rectangle going to be for this one? 1. Six minus 2 divided by 4 is 1. So each rectangle is, or each interval is 1 wide. Right-hand sum. So that means I'm coming from the right. Come from the right. Come from the right. Come from the right. Is this going to be an overestimate or an underestimate? Under, because all my rectangles are below the curve. So area is approximately. Now we just add up the rectangles. Okay, so again, if you look in the book, there's going to be crazy formulas in there. Ignore those. Like don't look at those. Just think, I'm just going to add up the rectangles. So that first rectangle has a width of 1 and a height of f of, here's the tricky part, it's not tricky, but it's the part that people mess up. F of what? For that first rectangle. What height do I want to use? Oh, okay, I heard 3 and 6. You could do it either way. If I'm starting over here, I would do f of 3. Every year there's a few people, Andrew, who want to do what you're about to do, and it's completely okay. He said f of 6. He was going to start over here and work his way this way. That's completely okay. Your terms will be like reversed from mine, but that's okay, especially for a right-hand sum. Some people want to start all the way on the right. That kind of makes sense. So what you were about to do would be fine. Second rectangle, width of 1, f of 4. Again, you start doing these and there starts to be a pattern. F of 3, f of 4, f of 5. F of 6. Again, it's completely okay, and some people like it for a right-hand sum to start on the right-hand side and to write their terms f of 6, f of 5, f of 4, f of 3. That's completely okay. Let's see. So the 1 doesn't matter. 1/3 plus 1/4 plus 1/5 plus 1/6. Safe stop. Who cares? We'll be done. Page 263, 25, 27, 29, 33, and 35. It's only 5 problems. I can't say only 5 problems. You got to add up rectangles every time. This is section 4.2, so if you're doing the calc chat thing and want to look at your answers, that would be where to find it. So I feel like I talked a lot longer. The length that I talked today was not related to how difficult the lesson is. Add the rectangles. That's Riemann sums. Draw the rectangles, add them up.